Okay, I'm gonna be explaining the how the principal quantum number, the magnetic quantum number, all are arranged for. I'm gonna explain with these two examples. I'm gonna write carbon 12, and neon. Oh shit, what was neon? Yeah, neon has an atomic number and its mass number, atomic number of carbon is 6. Atomic number of neon is 10. Okay. So, first, first we're gonna arrange before we arrange, I gotta show how I and what my professor taught me to arrange the orbitals. It's like, let's take 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d. And I believe it's good. Let's just write 5s. It's just gonna go like that. And we just draw an arrow from these, just crossing this. Now it don't start to make sense right now, but it will. So let's just take 1s, then we move to 2s, then we move to 2p, then we move to 3p, then we move to 3s, then we move to 3p, then we move to 4s, then we move to 3d, then we move to 4p, 5s, straight to 4d. How does it look? So let's just write 1s, 2s, 2p, 3s, 3p, 4s, 3d, I'm gonna write the rest down here. 4s, oh shit, come on. So 3d, then we're gonna go 4p, 5s, 4d, and we're just gonna continue, like maybe it's gonna be 5p here, yeah. So these go here and here. So for carbon, it's 6 electrons. 6 electrons. How 6 electrons are going to be? 1s2, 2 electrons in s orbital, 2s2, 2 electrons in 2s orbital. So now it's already 4 and 2p2. That's going to be in the 2p orbital. And now we got 6 electrons. Now for neon, it's going to be 1s2, 2 electrons, 2s2, 2 electrons, and 2p6. That's going to be for neon. Let's draw the Aufbau diagram. According to the Aufbau diagram, it's going to look like 1s, 2s, 2p. It's going to be again 3s, 3p, 4s. Just gotta draw the 3d. It's gonna be far 3d. Yeah, so 1s, we got 2 orbitals, two electrons in opposite spin, so we pair them up. 2s, the same, we pair them up, but for 2p, it's in a higher, we got three different orientation, like px, py, pz, and only 2 electrons are are filled in the p orbital. According to Hund's rule, we only be filling in, like, we could fill in this way and just call it a day. But no, according to Hund's rule, we gotta make sure if we don't have enough electrons, we're gonna just fill each individual orientation with an individual electron. Now the same for 1s, 2s, 2p. The rest, just like the carbon, we're gonna fill in case of neon, two electrons paired, and one, oh shit. 1, 2, 3. And this time we got all 6 of them. 1, 2, 3, 4, 5, 6. Yes. Now we got all 6 of them, and here carbon is all electrons are not paired. Therefore it's paramagnetic. Now what does paramagnetic mean? It means that when an external magnetic field is applied to this to this atom, it's gonna orient itself in a way that it's gonna be attracted towards this magnetic field. But in the case all electrons, right? In the case of neon, all the electrons in the outer shell are paired. It shows diamagnetism. Now diamagnetism is when we introduce an external magnetic field. The electrons induce themselves in a way that they try to repel, but it's a really subtle effect that we normally wouldn't notice. But higher external magnetic field is applied, we could notice the repulsion from diamagnetism, or repulsion as part of diamagnetism, while paramagnetism is attraction to an external magnetic field. And this is happening due to uh, unpaired electrons in the outer shell, whereas in diamagnetism it's paired electrons. Now here the principal quantum number is 2. The same goes for neon. The principal quantum number is 2, because yeah, we're at 2p, right? Yeah, that's what makes it. Now from what I have understood, how the electron how the atom is gonna look like, let's draw. This would be the 1s, this would be the 2s, and oh no, this would be the p 2p 2p, and as the only px and py are filled, we could say one of these would be px and one of these would be py. In the case of carbon, you could notice that z is not here, because the z orbital is not filled in. That's the reason the pz is not here. in the case of neon, we could see the z orbital. Like, I don't know if I could draw it in a better way, but that would be the 1s. That would be the 2s, px, py, and pz. One s, two s, px, py, pz. This is how the atom should approximately look like. And yep, that's what I understood about the atomic number, the principal quantum number, how it's arranged in the Aufbau diagram. This is the Aufbau diagram. Aufbau diagram. Yep. And yes, if I made any sort of mistakes, you guys could let me know in the comments.